Okay, go. Okay, so far you've looked at angles in triangles, or angle relationships in triangles, and quadrilaterals. So today we're going to talk about the relationship in polygons. There are two types. You have your convex and concave polygons. Most of the lesson will focus on the convex. So these are the ones where all the interior angles are less than 180 each, and the sum of the exterior angles will always add up to 360. Remember, the exterior angles were there. These were the interior. In terms of concave polygons, they can have an angle larger than 180, the interior angles, that is. And if you take a look at this, you can see that that angle is more than 180. So today we're going to focus on the convex polygons. All right, so some of the different examples are the triangles, the quadrilaterals, which one is this? This should be pentagon. Oh, that should say pentagon. Oops. The hexagon, heptagon, and octagon. So we know already that triangles have 3 sides, quadrilaterals have 4, pentagons 5, 6, 7, and 8. And this one might be a little bit tricky. So the number of diagonals from one vertex. And what that means, and I'll start with maybe a quadrilateral. If you were to draw one diagonal from the vertex, so I'll go back to triangles in a second, you would create a total of 1, 2 triangles, okay? In the case of a triangle, you cannot draw a diagonal from the vertex to give you more triangles. So that number here is 0, and we only have 1 triangle. If you think of a pentagon, okay, and you were to draw 2 lines, okay, diagonals, then you would end up having 1, 2, 3 triangles. So that number there would be 3. In the case of a hexagon, okay, you try thinking of it in your head. Draw diagonals from vertex. Well, how many can we draw? 1, 2, 3. So that number would be 3. And how many triangles are there? 1, 2, 3, and 4. So you see the pattern. Okay, and that continues on to say 4, 5, and 5 and 6. Okay? So the last column here, the sum of the interior angles, well, you already know that for the triangle. You know that these are the interior angles, and you know that they all should add up to 180 degrees, okay? And you learned the other day that in quadrilaterals that the sum adds up to 360. But if you just think about it this way, if you think of that as a triangle there, you know that in this triangle here, the angles add up to 180. Well, there's another triangle here. That's not a very good diagram. Let's just draw a bigger one. Maybe we can, nope. No, that's not working. Okay, that's fine. So if this has 2 triangles, well, you know the interior angles here add up to 180. That's a triangle. The interiors here add up to 180. So we learned the other day that all these add up to 360. We'll carry on the same concept onto the pentagon. So again, you know this adds up to 180. You know this adds up to 180. And that adds up to 180. So altogether, this would be 540. So where do these numbers come from? Okay, just erase that and that. So really, we got the 180 because it's 2 times 180. gave us the 360. Okay, in this case, it was 3 times the 180 because there were 3 triangles that gave us 540. So if we were to finish this column, 4 times 180, that gives us 720. And we notice a pattern here. So for any pattern, we can have some sort of equation to make our life easier if we want to predict. So finish that. That should say 1080. Okay? And in a second, you're going to see an equation so that you don't actually have to keep going on a table looking like this. Okay? Now we're going to apply this table to some questions in just a minute. All right, so some examples of regular polygons that you've already seen. Let's just redefine. A regular polygon is a shape in which all the sides have equal lengths and all the interior angles are the same. It's important because that table that we just looked at, okay, these are all regular polygons, just so that you know. Okay, and what we're doing in this column here applies only to the regular polygons, so that all the angles, the interior angles, are the same. Okay? Anyway, these are just some examples of the different shapes. So how can we come up with an equation so that we can save some time if we have polygons that have more than 5 or 8 sides? Okay. So in this equation, it relates the sum of interior angles, and that's your capital S here. This is the sum of interior angles. So that would be your last column here, okay? And this says 180 degrees. I can find the symbol. The N here represents your number of sides. So in the case of a triangle, there are 3 sides, right? In the case of a hexagon, there are 6 sides. So if you take the 180 and you multiply that by your polygon's number of sides and subtract 2, you should get the sum of the sum of all the interior angles for that shape. Okay? Now once again, you can only use this equation if you are looking at a regular polygon. Okay? Where all the sides have equal lengths. So really the rest of the lesson is taking a look at this equation here and applying it to questions. So you see that there are 2 variables. There's the variable S and there's the variable N. The questions could either ask you to solve for N or they could ask you to solve for S. If the question's giving you the number of sides, you can solve for S. If it's giving you the sum of all the interior angles, then you can solve for N. And it's just a matter of rearranging. So let's take a look at example 1. All right, so here we want you to determine the sum of the interior angles of a polygon. First one with 12 sides. Well, we just took a look at the equation. We know that the sum is equal to 180 times n minus 2. Okay, well, if it has 12 sides, then that means we're plugging in 12 for n, okay? And the equation tells us to subtract 2. So the sum will be equal to 180 times 10, and therefore the sum will be 1800 degrees. So the sum of all the interior angles of a 12-sided regular polygon is going to equal 1800, okay? Now you try the next one really quickly on your own. See if you can plug it in first. I'll wait maybe 30 seconds. All right, so hopefully what you did, you have S equals 180 times, well, this time I'm telling you the number of sides is 18, so it's 18 minus 2. So the sum is equal to 180 degrees times 16. Therefore, 2,880 degrees. So the sum of all the interior angles in an 18-sided polygon should be 2,880. Okay, let's take a look at the back side. Our second example here. Well, read the question carefully because this says find the measure of each interior angle of a regular polygon. So it's not asking you for the sum, it is asking you for each angle. So for example, if I had a 3-sided polygon, well, I already know that altogether that's going to be 180, but the question's asking me for each. So I want to know the angle of just one interior angle within that shape. So with a triangle, it could be easy to figure out, but with a maybe 9-sided or 16-sided, it could be more complicated. So how can we use our previous equation? Well, again, we know that the sum of all the interior angles is 180 degrees times n minus 2. What part of this equation do we have already? Well, we have n again. So that means we can find the sum of all the angles. Let's go ahead and do that. So 180 degrees times 9 minus 2. So that gives us 180 degrees times 7, which gives us 1260. Okay, so this is the sum of all the angles. How would I figure out the value for just one of those? Okay, well, let's think about that. So each interior angle will have to be this number, 1260. Okay, divided by, well, how many sides are there in this shape? There are 9 sides. Therefore, each angle must be 140 degrees. Okay, I didn't need any extra information. All that I needed was in the question already. I had to take this one extra step. Okay, so pause the video for a minute and try to do the other one on your own before you take a look at the answer. Okay, so I'm assuming you've unpaused now. Let's take a look at the answer here. So here you're plugging in 16 for n, okay? So 180 degrees times 14. So that should give you 2,520 as the sum of all the interior angles in a 16-sided regular polygon. Well, again, if I want to know for each, okay, each interior angle, okay, sorry, I didn't plan accordingly here. That would be 2,520 divided by however many sides I had, which was 16, and that ends up being 157.5 degrees. Okay, so not so bad here. So if you could guess, I made you plug in the values for n to find the sum or to find angles of each interior angle. Now, if you look at the third question, I'm probably going to get you to solve for n this time. So if you read the question, hopefully you see that. It says, how many sides does a polygon have if the sum of, that should be the sum of its interior angles is the following. Oops. Okay, so how do we attempt this question then? Well, let's just take a look at our equation once again. We know that the equation states the following. And this time, we know the capital S. So let's plug in what we know. Okay. So this goes back to our other units now. Now you're solving for a variable. Well, we want n by itself, so we're going to have to move over everything except the n. So I'm going to take my 180 and move it over, and then eventually I'm going to have to move over my -2, right? So if I do all of that, if I'm moving over the 180, I have to divide because I'm multiplying on that side, okay? And this will equal n minus 2. So if you calculate that, that turns out to be 11 is equal to n minus 2. So when you move the -2 over, it becomes 11 plus 2 is equal to n. So n is equal to 13. So my final answer is that this regular polygon has 13 sides. Okay? Pause the video, you try the next one on your own, and make sure you end up with the same answer as I do. Okay, so let's take a look at what you did. Again, we're using the same equation because we are given the sum and we're trying to solve for n. So in this case, 1,260. Okay? And when you move the 180 over, again, you are going to divide. Okay? That turns out to be 7. And when you move the -2 over, you're going to add it. So 7 plus 2 is equal to your n. N is 9. The shape has 9 sides. So the lesson isn't too bad. Hopefully you're comfortable with that equation. And we'll talk about it tomorrow if you have questions. Bye.